So in last classes we discussed motor physics, atoms, Bohr's postulates, Rutherford experiment, drawbacks, hydrogen spectrum, all this we discussed. Now let us see a part of motor physics. It is photoelectric effect. So basically what is photoelectric effect means, before entering into that, so if you want to remove an electron from the atom, you have to supply energy. To overcome the attractive force of electron from the nucleus. So this energy may be supplied by three phenomena. One is called as the atom emits electrons by three phenomena. One is thermoionic emission. Number two is field emission, and third one is photoelectric emission or photoelectric effect. What is thermoionic emission means? By the phenomena of heat, by supplying heat to the metal surface, atom emits electrons. By thermal energy, if electrons are released, we call that one as a thermoionic emission by heat energy. Field emission means by applying large electric fields of the order of 10 power 8 volt per meter. Electric fields of the order of 10 power 8 volt per meter. This is volt per meter. Then the electrons are emitted, which is called as field emission, by applying large electric fields of the order of 10 power 8 volt per meter. Then the electrons are released, and the effect is field emission. And finally, that third one is photoelectric effect, our class. Photoelectric effect. Now, what is photoelectric effect? What is photoelectric effect means? Here, this is a glass bulb. So what is basically photoelectric effect? Means when light off or electromagnetic radiation, we can say light is electromagnetic radiation. When light or electromagnetic radiation, this is what is called as light or electromagnetic radiation. When light or electromagnetic radiation of sufficient frequency, this word is very, very important. When light or electromagnetic radiation of sufficient frequency falls on a metal surface, this is metal surface, or you can call it as a cathode or emitter. Metal surface or cathode or emitter falls on a metal surface. The metal surface emits some electrons. These are called as electrons, and the effect is called as photoelectric effect. So when light of sufficient frequency is very, very important. Not all frequencies, sufficient frequency. When light of sufficient frequency falls on a metal surface, the metal surface emits some electrons known as photoelectrons, and the effect is called as photoelectric effect. So light of sufficient frequency falls on the metal surface. Then what happens? So the atom emits electron. How? I will explain. And this and the effect is called as these electrons are called as photoelectrons, and the effect is called as photoelectric effect. The metal which emits electrons is called as emitter or cathode or metal, and which collects that electrons is called as anode or collector. The current when electrons passes from cathode to anode, it gives some sort of current which is recorded by this ammeter, generally microammeter or simply ammeter, and the potential between the cathode and anode was recorded by this voltmeter V. This is a variable supply. Either we can use here, we can use a potentiometer type also, or a variable supply, variable resistance also you can use here, variable resistance also, or we can say a variable supply. Here see, if you observe this one, I have taken positive to the collector and negative to the metal. Therefore, electrons released here are repelled by this negative polarity. Electrons released here are repelled by this negative polarity and then attracted by this positive polarity given to the collector, and are reaching towards the collector. Here this is positive and this is negative, and this was observed or this was given by Hertz, discovered by Hertz. This photoelectric effect was discovered by Hertz in 1887. This was discovered by photoelectric effect was discovered by Hertz in 1887. Now, if you increase the negative potential here or positive potential at the collector, then what happens? More number of electrons are emitted from the cathode, and they are pushed towards the anode, or they are projected onto the anode. If we increase this negative potential or positive potential at the anode or negative potential at the cathode, more number of, if you further increase, the number of electrons will also increases. Then at some instant we reach a position where all the electrons are reaching from cathode to anode. That means in between cathode and anode we are having a space charge region. More number of electrons are there, and that region is called as a space charge region. We call that region as space charge region because the region between these two is filled completely charges in space, and we call it as a space charge region. Now these electrons what happens? Moves towards the anode. Now they move with some velocity called as some velocity, let us say Vmax or V, the velocity. And see, if you further situation is like this, this is called as photoelectric effect. Now if I reverse the potential, if we take this one as positive and this one as negative, if I reverse the potential, then what happens? Therefore, if the potential, let us say initially it is like this, now it is at 10 volts is applied. I am bringing down 10 volts to 0 volts or to 9 volts, 8 volts, 0 to volts, and -1, -2, -3. Then what happens? If I go on decreasing this one, then what happens? Here positive potential is decreasing. Therefore, what happens? Electrons will not be attracted more. If I bring it 0, very less number of slow, fast moving electrons will be collected. If I further go on increasing the reverse direction, if it changes the polarity here, this is negative and this is positive, and if you increase this potential, so -4 like this, then what happens? At some instant, the electrons reaching the collector will becoming 0. The electrons, if we increase this reverse potential, if it is positive and this is negative, electrons will be attracted. If I take this one as negative and this one as a positive, electrons will be repelled. Electrons are released here, the electron will be repelled by this negative polarity, and it won't reaches the collector. If it further increases, all initially may some fast moving electrons may reaches the collector. Initially maybe some fast moving electrons reaches the collector. But if I further increase the reverse potential, if I increase the negative potential here, what happens? All the electrons at some point stops reaching the collector, and that potential is called it as stopping potential V0. V0 is called as stopping potential. Stopping, very important, very important one. Stopping potential. Therefore, stopping potential is the potential or negative potential at the anode or negative potential at the collector, or positive potential at the cathode or positive potential at the emitter, so just stops the electrons in reaching the collector. So the potential which stops the electrons in reaching the collector is called as stopping potential. So stops the electrons in reaching the collector, stops the electrons in reaching the collector. Or if the electrons are stopped, then what happens? The current record will be zero. If the electrons reaching the collector is stopped, then the micrometer reads zero current. Therefore, at stopping potential V0, at stopping potential V0, the current is the photocurrent is zero. The photocurrent is equals to zero. The photocurrent is equal to zero. Therefore, we can say it stops the electrons is called as stopping potential, or it is the potential. Stopping potential is the potential, is the negative potential at the collector or anode, which for a zero reading in the galvanometer. So that is called as the something about stopping potential. Stopping potential means which just stops the electrons in reaching the collector. For a zero reading in the galvanometer, or for a zero reading in the ammeter, or for a zero current in the ammeter, that potential is called as stopping potential. Then what happens? The kinetic energy will be the maximum kinetic energy. Work done is here. Work done is equals to change in kinetic energy, or simply kinetic energy here. Then what happens? Then what is work done? EV0. We know that V is equals to W by Q. W is equals to VQ. W is equals to VQ. Therefore, here work done is equals to half mv square. This implies V is equals to W is equals to V into Q. V is stopping potential, negative potential, minus of V0. We reverse the potential. See, initially we have taken positive here, negative here, but now we have reversed it. Therefore, minus V0 into a charge of electron, minus E. Q is equals to minus E. V is equals to minus V0 is equals to half m. That electron, so the electron velocity is maximum velocity becoming zero. Therefore, Vmax square. This implies V0 into E. EV0 is equals to half m Vmax square, or EV0. EV0 is equals to half m Vmax square. This is very important. Therefore, the measure of kinetic energy is Ke is equals to, in terms of stopping potential, the measure of kinetic energy in terms of stopping potential is half mv square or Vmax square. Half mv square or Vmax square is equals to EV0. Here, this is velocity. Remember, no confusion. This is velocity. This is stopping potential. Okay, this is something basic introduction of photoelectric effect. Okay.